Hi there, hires. Welcome to a quick video that shows you the answers to A3. Please attempt it first before you watch the video. And remember that your answer, if it works, it's fine. It doesn't necessarily have to match my code. The beauty of programming, especially when you're getting into the more advanced stuff, is that there's more and more possible solutions that solve the answer. Obviously, your code might not take full advantage of the efficiency sort of measures that I might have in this code, or you might find that your code is more efficient than mine, because sometimes I don't always pick the most efficient answer. But if you've got any questions about any of the code or whether your one is correct or not, just remember this. If it works, if it generates the same answer as my code, just maybe in a slightly different way, as long as you're meeting the sort of key requirements of the task, then it is absolutely fine, okay? And the SQA would not penalize that. The focus on doing sort of the A tasks is to get you comfortable with using two's complement while also seeing how your programming is. So it gives me some really good time, really good opportunity to sit down with you and then spend some time talking about what two's complement is, just in case you've got any sort of questions or issues around why that's useful. We are building up the programs, so you should have seen the answer video to A1 and A2 by now. If not, go back, watch them, and ask me if you're unsure. But shall we carry on? So what we're doing in A3 is we're producing a separate program. So A1 and A2 are completely separate from this. We can't use any of the code really from that. And we're going to take in two binary sequences and we're going to add them together to produce a binary sequence. This is the advantage of two's complement, in that the computer doesn't really need to know how to do the different stages of two's complement. It doesn't have to undo the stages of two's complement. That's really done by the humans. What happens is that a two's complement negative number can be added to a positive binary number in a certain sequence, so an 8-bit number, for example. And if you're adding a negative number to a positive number, then if you work that out, if it starts with a 0, it's a positive answer. If it starts with a 1 in the binary sequence, then it's a negative answer. And then at that point, you can kind of prove that it's the correct negative number by reversing the two's complement. So you take away 1, you flip it back, and that should be the positive value of the negative number that the result of your sum is. I will show you at the end, and I'll show you in class if I've just confused you. So we are going to maybe use some of these functions. I just wanted to include it for completeness because it's always nice to know about these different functions. But there's actually a nice little format function which does a lot of the hard work for you. So I found that I didn't actually use bin with the majority of my answers. But let's take this code, or the design for the code rather, and put it into our replit. So in our replit, what we're going to do is, I've copied the instructions just in case we need to refer to them, but I'm going to start right back at the start. I'm just going to take all this out and do it again. So we're going to paste our design in, okay? And the design is get the first 8-bit binary sequence, get the second 8-bit binary sequence. The third line is set the new output to the first binary sequence plus the second binary sequence, and then output the new output binary sequence, okay? So there's a couple of things we can do, especially at NAT5 level, to very quickly, say this was a 4-mark question and you had to get each of the 4 steps of the program, which I'm just going to number now, implemented or built, then you could actually very easily get 3 out of the 4 by just saying things like, first, we'll call first sequence first equals to input, okay, enter first 8-bit binary sequence, okay, and I'm just going to duplicate that for the second one, and I'm going to change the word first to second, and I'm going to change the variable name first to second as well, okay. And then if I jump to step 4, I'm outputting, so printing is outputting, and I'm going to output the variable called new output, which doesn't exist yet, okay, which is why it's underlined. But step 3 is the sort of part where we're generating new output. So a couple of things to think about. Firstly, if I just quickly type in the sort of right-hand side here and say print high. I'm just going to check that this works. Okay, so what happens is the console runs the Python command. So I'm just going to test these things out. So if I say int and then put in 1010, okay, so a binary sequence 1010, comma 2. What that does is that takes the binary sequence and it converts it into base 2, and it returns the denary value of that binary sequence. So I'm expecting to get 8 plus 2, so I should get 10. Okay, and we get that. But just in case, I'm going to check it with another binary sequence, so 1111, okay, comma 2, and I'm expecting to get 15 here. If I get 15, I'm confident that this is the correct way to use it. Okay, so I'm happy with that. Now, obviously, it doesn't work with negative numbers, it only works with positive numbers. So just be careful and be aware of that. Okay, so the first thing I'm going to do is I'm going to set new output to be equal to the first binary sequence plus the second binary sequence. Now, when we did this on the board, I always showed you the binary sequence and then the denary number next to each other. And when you're doing binary addition, it's actually much easier if you know what the denary value of the binary sequence is. So in this case here, if I was adding 10 and 15 together, as you can see in the console window, 10 plus 15 is 25. I know it's late, but just in case your maths brain isn't on. So 10 plus 15 is 25. So I would be expecting to see a binary sequence that shows me 25, which would be 16 plus 8 plus 1. So that would be 5 bits. It would be 11001. Okay, so that's you remember that? Hopefully you remember that. So let's try this. So what we're going to do is we're going to convert the first variable into base 2, and we're going to add the second variable, or the variable called second, into base 2 as well. We're adding them together. So what we're going to do here is we end up with new output being a denary value which contains the number 25. Okay, and so if I run this program and type in 1010 and then 111, I'm expecting to get 25 as the number. So let's just see if this happens. I'm just predicting this. It might go horribly wrong. So the console is just slightly too small. So enter the first binary sequence. So I'll do 1010. Enter the second 8-bit binary sequence. I'll do 1111. Press enter. And I'm expecting to see 25. If I get an error, then we'll solve it. Okay, so I get 25. Excellent. Now this doesn't mean that it's completely, error-free, but it did what I wanted it to do. So I'm quite happy to move on. So that is not outputting a binary sequence. Now, if you use the function bin and pass new output into it, and then have an extra bracket at the end, this time it should show me the binary sequence for 25. Now, do you remember what the binary sequence for 25 is? Okay, it should be 11001. Okay, now what happens here is that because it's converted into binary, you get that OB at the start. That just means that it's binary. And then you've got 11001. So yeah, so that's 25. But it doesn't show us it in an 8-bit sequence. Okay, I know we have an input an 8-bit sequence, but it's definitely not showing us an 8-bit sequence as an output. So let's change what's inside the print. So we're going to use something called format. We're going to pass into it an integer called new output, which is the one with our value. And we're going to use this formatting code, which is O8B. Now, O8B will convert any denary number back into binary for you. So it should display any number as a binary sequence. So I do 1010 and 1111 as my second binary sequence. We know that it's converted to 25. So we should see 000110001. And that's exactly what happens. So we've finished our program. We've created the 4 steps to add 2 binary sequences together. And that's the hard part of our, one part of our 2's complement for the next program.